Welcome everyone to this session for August for the young birders. And today we have Suhail with us who will be talking about the bizarre world of brood parasites. And I hope all of you enjoy it and have a lot of questions to ask him. And uh, we hope that we have a lot of interaction that happens. Just some ground rules before we get started is like I first mentioned, we have kept you on mute and you can't unmute yourself. But at any point, if you have any questions, you can raise your hand and we will let you unmute. Or you can preferably use the chat box when the speaker is speaking. If you have any questions, use the chat box. If you have any clarifying questions or any doubts, you didn't understand what they are saying, at that point, you can use the chat box to ask your questions, and we'll try and take the questions then itself to help you better understand. But for questions which need a lot of discussion, which need a lot of back and forth, and which is not directly related to the topic or the presentation, for those, what we'll do is we'll take them at the end of the session where we have a dedicated Q&A section. Okay. Yeah. So before I uh, hand over to Sohail to get us through the world of brood parasites, just for people who are new and who just to introduce you to what Early Bird does. So these sessions are organized by Early Bird, which is an not-for-profit initiative at Nature Conservation Foundation. And what we do is we our main motive is to get kids like you all closer to nature. And how we do it is we do make a lot of material. Some of you might have also seen or played with us some games, some use the flashcards, seen the flashcards, our pocket guides, or we conduct such webinars or workshops for kids, and also train teachers who can help us achieve our aim of getting kids closer to nature. So that's about what we do. And for our speaker today, Suhail, he for pocket guides, or we conduct such webinars or workshops for kids having some trouble. Just a second. You also hear my voice echo, or is it just me?
Your voice is fine, Amrita.
Okay, so it's probably something at my end. Okay. So to introduce our speaker today, he says that he's been fascinated by birds and bird behavior since he was teen, so almost your age. So and he's done research on breeding behaviors and brood parasitism, and that's what he's going to share with us today as well. And we hope that all of you have great time where learning more about these interesting behaviors that birds have. And now he says that he spends his time getting more people fascinated by nature, and that's what and that's one reason why he's here, and to share his uh, like what fascinated him about learning about brood parasitism and all of that. So over to you, Sohit. Just one thing before that, uh, for questions, since this is a session for kids, we'll give priority to questions that come from kids, uh, and will encourage kids to ask questions as well. And at any point, if there are adults in this Zoom session, we will you can ask questions, but then the priority will be given to the kids as this session is aimed towards them. Yeah, over to you, Sonia. Thank you for joining us today.
Great. Thank you so much, Amrita. And thanks to you and Early Bird for this opportunity. And of course, thanks to all of you young people here who have taken the time on your Sunday morning to join us. I know there are many more exciting things to do on a Sunday. Um, so what we are going to talk about today is this strange and bizarre phenomenon. And of course, the particular strangeness can be seen from videos such as this. So let's take a quick look. So we see this tiny bird feeding a massive bird here, again over there, and another example. And in all cases, the small bird is the parent bird actually feeding the chick. But the chick is not its own chick. It is the chick of another species, in this case of a larger species. And you see these absolutely ridiculous kind of sights and photos where this tiny bird is sometimes perching on the shoulder of the big bird and feeding it. So our question, sort of our topic today, is to try and make sense of this. What is this phenomenon? How does it work? What do the different interactions, what do the players do in this phenomenon of brood parasitism? So to begin with, sorry, I didn't mean to play that again. So to begin with, let's just us talk a little bit about this. So these birds, the big chicks that you saw, are chicks of brood parasites, and brood parasites are species that lay their eggs in the nests of other species. So we can talk about the parasite species and the host species. So parasites lay their eggs in the nests of hosts, and then they leave the hosts to it. The hosts have to do all the rest of the work, incubation, raising the chicks until until they can fly themselves, and so on. And so that's why they're called parasites. They're not parasitizing the tissues of the host like we think of parasites, but they're parasitizing the parental behavior of the host. And a brood, of course, the reason they call brood, a brood is the family of a bird. That's what brood is. So they're brood parasites, not conventional parasites. Um, and then you may think, okay, this is a bit strange, is this just a one-off thing? Just a few species do it. We have famously in India, of course, the koel, which parasitizes crows among other species, and we know about them. And by the way, in India, we know about the koel and crows for thousands of years. In old Sanskrit texts, there is a reference to birds that leave their offspring to be raised by others. And across the world also, there are folk tales about brood parasites, about cuckoos and so on. And it turns out that about 1% of bird species are brood parasites like this. So that's about 100 species of birds, which are unable to build their own nests and take care of their own young, but they outsource this job completely to the parasite species, the host species. And among these 100 birds, species include a whole bunch of cuckoos, like the koel and the common cuckoo and other cuckoos. There are large numbers. And there are other non-cuckoos there in the North America, sorry, in the Americas, there are a group of birds called cowbirds, which lay their eggs in the nests of other species. Then there are honey guides in Asia and Africa, and there are African parasitic finches, including the whydas and widow birds. And there is also one parasitic species of duck in South America. So this is a phenomenon that seems to have arisen multiple times. But the question is why? It doesn't seem to make sense to us as humans. Why would you just abandon your young and let them be taken care of by others? And of course, people who study this, people who study animal behavior and evolution of animal behavior, they have a particular way of thinking about this. They say, okay, let's understand the costs and the benefits of doing this. So let's just think of the costs. Now, because brood parasitism is about reproduction, I want you to think about what are the different costs of reproduction for birds. So where do birds have to expend the most effort when they are reproducing? So think about the different kinds of things they have to do. So females have to produce the eggs. That can take a lot of effort and energy. Then the birds have to build a nest, which can also take energy. Then they have to incubate the eggs until they hatch. And after hatching, they have to keep the young safe and also feed them. So there's going to be a poll coming up just now, and I'd like you to think about and vote for which of these several activities that birds do, which do you think is the most effortful or the most costly? Amrita, can you launch the poll?
So when I launch the poll, everyone will get a pop-up on your screen, and you'll see a question and the multiple options. You have to select whichever you think is the answer. I've
Hmm.
launched the poll. You can
So,
start
which part of
answering.
breeding do you think is the hardest? Making eggs, building a nest, incubating eggs, or raising, feeding young? So, just click and see. Let's see what people think about this. That's great. Yeah, we'll wait for a few more answers to come in. Okay, we've hit over 50% of you in the Zoom room here. I've answered nearly
Yes.
everybody. Um, so it's interesting. So you voted for all possibilities. The fewest people think that making eggs is very costly, or incubating eggs is costly. Building a nest, some of you think is quite costly, and feeding young, most of you think is costly. And that's roughly the order in which it is actually the case. So making eggs, yes, it is difficult. Females have to mobilize lots of calcium, lots of protein to make eggs. That's true. But it's also true that actually female birds can lay more eggs than they actually do. And in many species, in fact, what are called indeterminate layers, you don't have to remember the jargon. But if you sort of cunningly remove eggs as they're being laid from the nest, then females will just lay more and more eggs. Not all birds do this, but quite a few do this. Building a nest is time consuming, of course, but remember, it's only a one-time thing. So you don't have to do it all through the breeding season. It takes a few days, you build your nest and you've got it. Incubating eggs, of course, the time taken for incubation is time away from, for example, feeding. So if you're incubating for 2, 3 hours or longer, then you're not feeding at that time, and you have to make up for that when you're going out and feeding again. But it turns out actually that feeding, taking care of the chicks in the nest and feeding them, that's the most costly, the most difficult thing for birds to do. And I'll tell you some interesting, the reason, how people know this, how scientists know that this is. So some bird researchers have it's a slightly cruel trick on birds, several species. They've given different families or different parents different numbers of chicks to care for. So if the species like a blue tit or gray tit in Europe, if it normally has, let's say, 5 or 6 eggs and chicks in the nest, they give some parents only 1 or 2, and they give other parents 8 or 10 to raise from when they hatch. And it turns out, and then they check and see how well are they able to raise the young, and what happens to the parents later. And it turns out that actually parents can raise many more young than they usually produce, but they have to pay a cost. So parents who are made to raise more young, they have a lower survival rate to the next breeding season. So they tend to die at a higher frequency. And if they do survive to the next breeding season and they breed, they lay fewer eggs than they did the last time, and they are able to expend less effort in breeding in the next year. So this indicates the survival going down, and the lower breeding, if they do survive in the next year, indicates that there's actually quite a high cost to the raising the chicks. So that's when you give them different numbers of chicks. But if you give them different numbers of eggs, to incubate, that doesn't have so much of a difference, an effect. So we think from that actually raising young, feeding them and so on, taking care of them takes a lot out of these little birds. And so you can see how being a parasite then makes sense again from an evolutionary perspective, because then I can lay lots and lots of eggs, but I'm not bearing any of the cost of raising the young. Others are bearing the cost. And so from that perspective, you could say, the question is not really why are there brood parasites, but the question might be why are there only so few brood parasites? Why are there only 1% of birds, 100 species parasitizing other species? There should be more. We don't know the answer to that question, but it's when you know a little about the phenomenon and you understand a little deeper, it's interesting that the question can flip itself. from an evolutionary perspective. Um, okay, so this is great. I'm a parasite, a brood parasite, and I want to lay my eggs in other birds' nests. But it's not really so easy. I can't just, any bird can't just pick up and go and lay its eggs in another bird's nest. Presumably, I need some tricks. I need some tricks that will help me be successful at parasitizing other, hosts' nests. So I have a question for you then. If you were, you could design a brood parasite, the perfect brood parasite that, remember, brood parasite needs to lay its eggs in other hosts, in host nests. Those hosts need to accept the eggs and raise the chicks as their own until they are independent and leave. So if I were to wanted to design the perfect brood parasite, what kinds of tricks would I bestow upon it? What kind of tricks would I give it? So this is a open-ended question for all of you. Amrita, if you can paste the question in the chat box, there it is. And this is not a multiple choice kind of question. So you are free to type in the chat box what kind of tricks you would bestow, you would give the perfect brood parasite. Or if you would like, you can also raise your hand and Amrita will unmute and you can speak. But just ensure that I'm asking a very specific question. So if you can keep your answers to that question itself. What tricks would you give a brood? Or if you were a brood parasite, imagine we think of it that way, then what kind of tricks would you have up your sleeve in order to be successful at your brood parasitic ways? Anybody has any ideas? Okay. Mimic the eggs of the host, a voice that could mimic the call of the host. Okay, what would that do? Why would you want to mimic the call of the host, Chetan? Remember, you can type, but you can also raise your hand. So the question is, Avani, the question is, if you were a brood parasite and you knew that you had to put your eggs in other birds' nests, then what kind of tricks would you try and have up your sleeve to be successful? Eggs look like the other bird's eggs. Okay, thanks. That was mentioned. You would eat one egg and lay one egg. That's very interesting. Yes. Mimic the eggs and voice of the host.
And
And
Anurag has raised his hand. So
Yes.
what? Go ahead, Anurag.
and the parasite species might also trick the host species by throwing away its eggs and putting its eggs.
Yes.
So there will be equal number of eggs and the host species will not get confused.
Yes. Yes. Perfect. Thank you. I think that also came up in the chat box. So the idea is that if the hosts know how many eggs they have in the nest and suddenly there's an extra egg, not laid by the female, then she might think, oh, this is strange, and she might do something about it. So, of course, I should say that it's a bit controversial about whether birds can count. Some species research has been done to see that they can count, but you can also imagine it's not necessary for them to count 1, 2, 3, 4, because even just visually, 5 eggs looks like more than 4 eggs. You don't have to be able to count to 5 to know that there's something extra going on. Keep track of the timing so that I can keep my egg when the host is not there. Okay, this is great. So lots of excellent ideas have come up, and we'll discuss some of these ideas, and we'll discuss some ideas that have not come up yet. So lay the egg when the host is not in the nest. Okay, so let me share with you um, some tricks that we know. Some you've mentioned, some you've not mentioned, and hope you can see my screen. Um, so one trick that no one has mentioned so far is for you to look dangerous. So on the left here, we have the common hawk cuckoo, which is the species found all over India and is a brood parasite. And it looks like a shikra, which is on the right. Shikra is, of course, a dangerous bird. It's a predator. It catches other birds and feeds on them. And we don't know exactly why these hawk cuckoos and many cuckoos actually look like predatory hawks. But one possibility is that they scare the bird off the nest, scare the host off the nest, and they could quickly come, lay their egg, and then go away. In fact, something like what many of you have said, lay an egg when the host is not in the nest. So that's one possible trick you might have up your sleeve. You need to lay your egg at the right time. So not just at the right time that when the host is not there, but you also have to lay your egg uh, while the host is laying her eggs. If you can't lay an egg in an empty nest, right? Because then the host may know immediately there's something wrong. Okay, I never laid an egg here, and now suddenly there's an egg in the nest. And you also probably don't want to lay your egg too late after the host eggs are all already laid and incubation has already started, because then you might hatch also very late. And hatching late is bad because you can imagine then all the other chicks are already grown up and then you are small and you may not get enough food from the parents. So you have to lay your eggs at the right time, which is typically after the first host egg has been laid, but before the last host egg has been laid. So you have to keep a close eye. And recent research has shown that actually female cuckoos keep a close watch on the host nests, and they keep visiting the nests and they check and see that they know what eggs are already there and how they're being laid and when they should lay their own egg. So you need to lay your egg at the right time. Many brood parasites also have this extra trick, which is to make very thick eggshells. Because what happens is that they come in and they lay their egg and leave very quickly. So they're often dropping their egg from a height. And while doing so, they can damage their own egg. So they make thick eggshells, in fact, something like 20% thicker than the hosts. And instead, what sometimes happens, as you can see with the red arrow here, that the host eggs sometimes get damaged. So the brood parasite doesn't want its own eggs to get damaged. The host eggs getting damaged is not so much of a problem. And you can see that because they're dropping eggs from a height and their eggshells are thick, sometimes the host eggs get damaged. They also tend to have a short incubation period. So this is a chick of a common cuckoo in Europe, but common cuckoos are also found in India. And what happens is that they have a very short incubation period so that they tend to hatch before the host chicks hatch. And of course, the advantage there is that then before the host chicks hatch and any competition can happen, they are already grown up to some degree and they've got all the food the parents can bring. So many brood parasites, not just the common cuckoo, have a shorter incubation period so that they hatch early and can get the resources and the food to have a head start on the hosts. They also have an additional, the chicks have an adaptation to beg for food like crazy. So this word beg here is used by animal behavior researchers to describe what chicks do when they are asking for food. And how chicks of birds ask for food is that they raise their heads like this one, they open their mouths fully, showing the inside, and they make a big noise, a begging, what's called a begging call or a begging sound. And this seems to stimulate the parent to come and feed that chick. And here, this is, I think, a cowbird chick from North America, and all the other host chicks are in the nest with it. And it tries to get most of the food by begging the most. And parents tend to respond that way by feeding them the most when they beg the most. And in addition, other species also tend to, the inside of the mouth also stimulates the parents to feed them. And you can see here on the left is a parasitic species, and the right is a host species, chick species. There are two different species, but the parasite has similar mouth markings that stimulate the parents to feed it. So they also do that. They don't really beg in a particularly loud and vigorous way, but sometimes they've evolved these kind of markings as well. And finally, and this is not finally, there are many such tricks, but the final one that I'm going to end with is that for some parasites, about half of the parasites, the brood parasites they are, the chick hatches early and then it throws out the eggs, or if there are any other chicks in the nest, it throws them out of the nest. So I'm going to show you a little video on this. I hope it's not too distressing. Here we go. There we are. So here's a parasite cuckoo chick that's trying to throw out the chick of the host. This is a redstart host, I believe. And here's the cuckoo chick throwing out the chick of the reed wobbler host. So these cuckoo chicks, these parasite chicks, have an instinct in which when they hatch and they have a little energy, as if they feel anything else in the nest with them, they instinctively kind of try and get them, balance them on their back. And by the way, they have a depression on their back, a little concave depression on the back that helps them with this. Balance them on their back with their little stubby wings. They try and get rid of whatever is in the nest with them. And you can see that these are the kinds of birds where the chicks are born blind and without any feathers. So they're doing this, by the way, completely blind. They're hardly a couple of hours old after having been hatched, but they have this instinct to throw the eggs and chicks out. And you can see in this particular still, you can see the eggs are, one egg is thrown out of the nest already. So, sorry, there we go. All right. So the reason that the cuckoos do this is, I've sort of said already, it's kind of obvious that if they are alone in the nest, they get all the food, they can grow that much faster, and they can develop and leave the nest. But not all not all brood parasites do this, about half do. So we've spoken about the brood parasite part of things, and they have various tricks in research or scientific parlance. We call them adaptations because we imagine that evolution, evolution by natural selection has led to the the development of these different kinds of behaviors, and those are called adaptations. Adaptations, any behavior or anything aspect that helps the organism survive and reproduce. So that's fine. But the hosts, what about the hosts? The hosts are not just passively sitting over there waiting for all this to happen. You would imagine that any host that has any kind of defense, any kind of adaptation, or we can call it counter adaptation. Let's say it recognizes the egg, or it tries to chase away the brood parasite. Any host that happens to have a slight behavior towards that in that direction would be more successful at avoiding being parasitized, and then their offspring would also inherit that behavior if it is heritable. And this is evolution by natural selection. That behavior, the defense behavior, would spread through the population. So that's exactly how evolution by natural selection works. So now, earlier I asked you if you could design the perfect brood parasite, what tricks would you give it? What adaptations would you give it? Now let me ask you the opposite question. If you were to design the perfect host, what kind of adaptations would you give it to defend itself against the parasite? So what kind of defenses would you bestow upon the host species? Again, you can type in the chat box, or you can raise your hand and speak. So the question is, what defenses against parasitism would you like to have if you were a host or a potential host? Throw the egg. Excellent. So to be able to throw the egg, you need to be able to recognize that this is not your egg and then throw it out. That way you can save yourself. Yeah, absolutely. Anything else? We'll come back to that question, Isha. Yeah. Count the number of eggs and find the extra one. Correct. And then if you can identify which is the extra one and you know it's not yours, you can throw it out. Absolutely. Yeah. Chase the parasites. Yes. Excellent. Yes. 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 Actually, it turns out that in most brood parasites, the brood parasites are much larger than the host. So they parasitize hosts that are, half their size or even smaller than half their size. And so it's not very easy for the host to chase the parasite. The exception is the quail and crow, where the crows are actually larger than the quail. And in you may have seen this, crows actually do chase coils away. They make a largeness, sticky substance, but cannot throw, do not feed the chick. Okay, lots of really nice ideas. So I think broadly we can think of the defenses that the hosts have in a few different categories. One is if they can see that they are parasitized because there's an extra egg or more than one extra egg, especially if immediately before that there was a brood parasite somewhere near the nest. Then you can do one of two things. If you can't tell if there's an extra egg or which one is not yours and so on, you can just abandon. You can abandon the nest. That is, you can say, I'm giving up on this nest because the risk is too high. I'll just go and start another nest and lay eggs and hope for the best. And many birds do this. They abandon the nest if the risk of parasitism is high, if there's a parasitic eggs in the nest. The second is if they are able to recognize that the egg is not their own, and which one is not their own, they sometimes try and puncture the egg so that it doesn't develop. Or if the egg is not too large, they lift it out and throw out the parasite egg. So they may be able to remove the parasitic egg and everything is fine. So another possibility is after hatching, they are able to recognize the chick, that the chick is not theirs, and they remove the chick or don't feed the chick, like several people have mentioned. It turns out that the abandoning nest and the recognizing eggs is a common defense that host species have. But recognizing chicks is not common at all. Only very, very few host species have some recognition of chicks. Why that is something we can discuss later, but this is just to tell you, this is the kind of thing that people have seen. So if we come back here and we think about this again in kind of evolutionary terms, we can think about the hosts, the parasites, as having some kind of trick, a set of tricks, actually a toolbox of different tricks, which in scientific terms we call adaptations. If they have those tricks, then hosts will be under evolutionary pressure to develop defenses against those tricks, or sometimes we call them counter adaptations. So for example, I'll take as many of you mentioned, eggs. So the parasite has a trick to lay eggs in some way in the host nest. The host evolves a defense, which is to recognize the eggs, that this is not mine, and throw them out. And that would lead to the parasite being under pressure to evolve a counter adaptation, which is to have their eggs mimic the eggs of the host. So we can get the mimicry of host eggs through this cycle of adaptation and counter adaptation. There's a human analogy to this this evolutionary situation, and the analogy that people have drawn is from in human terms between countries. There's something called an arms race. Arms here referring to weapons. So there's a race for weapons. There are two countries that are enemies or rivals, and the classic example of this is the US and the Soviet Union after the Second World War, where each of them felt threatened by the other, and each of them developed nuclear weapons. And each of them felt threatened as long as the other country had more nuclear weapons. So if the US had 100, then the USSR had to have 150, and then the US had to have 500, and then Soviet Union had to have 1,000, and so on. And it kept escalating and escalating. So every additional 100 or 1,000 nuclear warheads developed by one country was met with more warheads developed by the other. And of course, it can spiral away. It's a never-ending kind of thing. In human societies, of course, we can negotiate and we can come to some kind of resolution, which roughly speaking was what happened with the US and USSR. But of course, in the natural world, in evolutionary terms, negotiation doesn't happen. So we tend to see the cycle of adaptation and counter-adaptation. So let's take this idea and apply it to a system that we know about fairly well, which is with quails and crows. And all of you know this, of course. You can see, you know what the quail is. The quail is a cuckoo. And you can see a female quail here on the top right, and then male quail. And quails are obligate parasites. They have to parasitize other birds. They are unable to build their own nest. They never do. And they mostly, at least in India, they mostly parasitize crows and mostly house crows, which you can see in the bottom right. Now, this is not the only species that parasitize. They do parasitize other species, but by and large, this is the the most common host of quails and crows, of quails. So we can ask ourselves, okay, so that's fine. Let's try and look at some of these features. You know that I just mentioned that quails are smaller than crows. They actually sometimes in the breeding season, crows chase and kill them. Crows really don't like quails. But we also think of crows as extremely intelligent. So how is it that they allow themselves to be fooled into raising quail chicks? So just to show you some photos now, this is um, a photo of the eggs of quails and crows. So crows have this kind of bluish egg with lovely speckled patterning, and they're a little larger than quail eggs, which are greenish brown, and they have this brown kind of patterning. Um, and the chicks look like this. They look fairly different. These are newly hatched chicks, coil chicks on the left, they're very dark, the skin color. Remember, they hatch without feathers, and crow chicks have a pink skin. Um, and these photos are taken by my colleague Sumit Sinha, whose work I'm going to describe next. So we can try and understand the sort of cycle of adaptation and counter-adaptation using this system, this model system of quails and crows. What questions can we ask? What kind of research questions can we ask to ease our puzzlement, increase our understanding of the system? And perhaps we can take particularly the example of the eggs, right? So we can see that the crow and quail eggs look very different to us. But on the other hand, they're not entirely different. You could imagine the quail eggs could have been solid red color, like some birds have a solid brick red color egg. But quail eggs don't look entirely different, nor are they exactly the same. So maybe we should be asking ourselves, and some people have said this, some researchers have said, oh yes, they've said quail eggs mimic the crow eggs. That is, the quails have evolved egg color that looks like the crow egg, so the crows don't detect the egg and don't throw it out. So this is an interesting question. How could we answer this question? How could we ask ourselves, or how could we ask the birds actually, do the quail eggs mimic the crow eggs? How can we find out? So I want you to think about how could we find this out, whether the quail eggs mimic crow eggs. In other words, whether crows can't tell the difference between the quail eggs and their own eggs. So again, something for you to answer in the chat box or to raise your hand. Yeah. How would we, as young researchers, how would we find out whether crows can tell the difference between their own eggs and quail eggs, or whether the quail eggs mimic the crow eggs, and so therefore crows can't tell the difference? How do you think we can do that? It's a tricky question. We can't ask the crows, right? We can't ask animals about what they think, about what they feel, what they know. Well, we can ask them that, but they can't reply to us. They can't in speech. But perhaps there's a way to ask them the question that doesn't rely on them talking to us. Any thoughts? How can we find out if quail eggs mimic crow eggs? You can observe the crow in the nest, yes, but that's not sufficient. We have to do something, no? We have to do something. Maybe they can smell their own egg. That's fine. But this is all maybe, maybe. But how can we actually find out? Okay, so let me suggest one possibility. One possibility is that I take a quail egg and I put it in the crow's nest and see what is done. So I take a quail egg and put it in the crow's nest. And I'm not going to use a real quail egg. I'm going to use an artificial egg because I don't want to take a real egg. There's some ethical issues with that. I make an artificial egg out of resin or something like that, and I paint it to look like a quail egg, and I put it in the crow's nest. Now, suppose I do this, and here's a question for you. and Amrita is going to put a poll again. Suppose I added a coil painted egg to a crow nest and found that crows are fine with it. Okay, so I put the coil egg in the crow's nest and the crows are perfectly fine. What can I conclude? Amrita, can you put the poll? Or maybe you have it. Yeah, here we go.
The poll
Yeah.
question says, suppose I added a coil painted egg to a crow's nest and found that crows are fine with it. What can I conclude? The options are coil eggs mimic crow eggs, coil eggs do not mimic crow eggs, can't really conclude anything.
Okay, nice. Yeah, so about half of you have answered. So, and most of you have said that if the crows are fine with the coil-looking egg in their nest, we can conclude that coil eggs mimic crow eggs. That is, coils have evolved to produce eggs that look like crow eggs. Now, there is one problem with this, though, which is that it's possible that crows will just accept anything you put in their nests. Maybe I'll put some weird looking, a round object of any color. Suppose crows don't discriminate at all, right? Then they will accept the coil eggs. And that doesn't mean that coil eggs are mimic the crow eggs, because crows accept anything. So there's no reason for coils to mimic the crow eggs. So the question then is, how can I rule that out? How can I rule out the possibility that crows will just accept anything in their nest? And in this experiment that my colleague Sumit did, he added another, this is an experiment, so he added another what's called an experimental treatment or experimental condition. So in some nests, he put a coil painted egg. In some nests, he put a black colored egg. Black colored egg is completely different from a crow egg. It's also completely different from a coil egg. And as a matter of fact, he didn't just do this. He put two kinds of, I'm calling them odd looking eggs, odd painted eggs. So this is a coil looking egg. This is some polka dotted egg, which is quite different. And this is a black egg, which is entirely different from a coil egg and also from a crow egg. Okay. And what he found when he did this is that the crows really don't like these eggs. Yeah. And they throw them out. They don't like the polka dotted egg and the black color egg. Correct? But we still have to worry about a third possibility. Third possibility is that our artificial eggs aren't very good at all. Maybe our artificial eggs, the texture is strange, maybe they smell strange, maybe there's something that the crows are detecting, and that's why they're throwing out these artificial eggs. So can you think of what sort of additional condition do we need to check whether our artificial eggs are actually able to fool the crows? Can you think of any additional experiment that we need? Are we good enough at making artificial eggs to be able to fool crows? So I'll just go ahead and answer that. The additional thing is exactly. So Shakti said, and that's exactly right, put an egg like a crow's egg. Perfect. Okay, so let's recap over here. If the crows will accept anything in the nest, then they will also accept these very bizarre polka dotted and black eggs. If our artificial eggs have a strange smell or a strange texture that the crows don't like, then even when we paint them to look like their own eggs, they will remove the egg. And that means we can't proceed with the experiment, because if the crow-looking egg is not accepted by the crows, then the rest of the experiment doesn't make any sense. Yeah, I hope that makes sense to you. And so what we want ideally is that the strange-looking eggs are removed, the crow-looking eggs are retained, and then we can see what happens to the coil eggs. Okay, so and just to convince you that they really look like the real eggs, here are two photos of a clutch of crow eggs and a bunch of coil eggs, and the arrow points to the artificial egg. And hopefully you can see that they're really, really similar because Sumit was an excellent artist and craftsperson, and he made very convincing looking artificial eggs. Okay, so here's the setup. Let's go through some of the results. So number one, the crow eggs, crow-looking eggs, these are all artificial eggs. Crow-looking eggs are accepted by the crows. What does that mean? It means that the artificial eggs worked, right? And we're able to proceed with the rest of the experiment. Next, the polka dotted and black colored eggs, like I said, they were removed by the crows. So that doesn't mean that, so it means that crows don't simply accept anything in their nest. And for our purposes, it means that crows do discriminate. So now the question for you is, what do you think happened with the coil-looking eggs? Did the crow hosts accept them like their own eggs, or did they chuck them out like the odd-looking eggs? So there's another poll for you in the popping up now. What do you think happened? This is a real experiment, happened in real life. So the crow eggs were accepted, the black and polka eggs were removed. What do you think happened with the coil eggs? Okay, you think, most of you, all of you so far think that the coil eggs sufficiently resemble the crow eggs that the crows simply accepted them. Okay. Okay, nice. Great. One person disagrees, they were removed. And as it turns out, the result is not one or the other. Sorry. It's actually a mixture. About 60% of the coil, or 60% of the times, the coil eggs were accepted, 40% of the times they were rejected. So this is not a complete black and white answer. The answer is mixed, and it indicates that coil eggs do mimic, and we can say they mimic because they did better than these eggs, but they don't mimic perfectly. And the reason we say not perfectly, because they didn't do as well as the crow eggs. Does that make sense? The coil eggs mimic, but not perfectly. So in some 30 to 40% of the cases, the crows were able to discriminate and see that this is the coil egg, and they chucked it out. So we've shown that obviously the coils lay their eggs in the crow's nest. The crows do have some degree of defense because they are discriminating. The coils have evolved partial mimicry to this, which is able to most of the time overcome the crow's discrimination, but not all the time. Okay, so let's just end with some summaries. So we started out talking about the cost of raising kids. And so there are good evolutionary reasons to outsource your child rearing to others. And that's why we see the evolution of brood parasites. Now, although these are good evolutionary reasons, they're obviously not good moral and ethical reasons. And morality and ethics is a human attribute. And so, so just because we see it in nature doesn't mean that it's moral or ethical for us to do it. By the way, this is why we don't take our morals or our ethics from nature. Second, that brood parasites and hosts are sort of in this evolutionary adaptation and counter-adaptation arms race. We expect that any new adaptation or fine-tuning of adaptation by one should be met with some further fine-tuning of the adaptation by the other. And we call this an arms race, by the way, because of this analogy with the human societies and human countries. And we see this, by the way, this arms race in many kinds of interactions where there's some negative interaction. So between predators and prey, for example. So, in the African savannas, the antelope and gazelles have evolved fast running to escape from cheetahs, and cheetahs have evolved to run even faster and faster. And there are various adaptations they have for this. Or between the regular pathogens and their hosts. So we have bacteria and viruses infect us. We have various defenses against those bacteria and viruses, and the bacteria and viruses evolve counter adaptations against those defenses and so on. So this is a very common phenomenon. Everywhere you look, where there is some negative interaction, you will see this evolutionary arms race. And even though all this we're talking about has happened in the past, all this evolution has happened in the past that has resulted in what we see today, we can still try and understand what has happened in the past by asking clever questions about what we see today, right? We can't go back in, thousands of years or millions of years in the past to see how this arms race has happened, but we can still look at the outcome of that and ask clever questions about it. And this is the stock, technique of researchers who work in ecology and animal behavior. And finally, since animals can't talk, we need to be creative about how we seek answers to the questions, because animals can still tell us answers, except they can't tell it to us by talking. But they can tell us answers to to our questions through their behavior. So those who study animal behavior, as I've done all across the world, we try and find clever and creative ways to get animals to answer our questions through the way in which they behave rather than the way in which they talk, because they can't. So I'll stop there, and we have time, I think, for questions, and I'll also look through the chat and see if there are any other unanswered questions. Yeah, thanks again for joining. So feel free, Amrita, I don't know if people can put the
Yeah,
question in the chat box, but also maybe unmute.
yeah, you can raise your hands and unmute. We'll unmute you to go ahead and ask questions. There are a few questions in the chat which I'll read out. The
Yeah, sure.
first one was some they asked if a bird can lay eggs in like target many species for like
Yes,
when
yes.
good parasites.
Yes, yes. In the best, some of the best studies. So there are brood parasites that are specialist that target only one or very few species. All right, and you can imagine if they target that specialist species, they can also evolve their tricks that are suited specifically to those species. Right, but there are some brood parasites that actually lay their eggs in a large number of different species. So, for example, the cowbirds in America, North America, brown-headed cowbirds, they are known to lay their eggs in over 200 host species. And the common cuckoo in Europe is known to parasitize over 100 host species. And you can imagine there, one question that arises is, if you are targeting so many host species, how can you have this egg mimicry thing happening, right? Because every host species or different sets of host species have different colors and patterning on their eggs. So you think that the generalist brood parasites that target many host species, they can't have any kind of egg mimicry. But it turns out that in a few cases at least, there is such targeting. So in common cuckoos, different females lay different types of eggs. So there are some females that specialize on some parasites and other female hosts, and other female cuckoos specialize on other hosts. So there's the reed warbler, the common cuckoos who specialize on reed warbler nests, common cuckoos who specialize on dunnock nests, common cuckoos who specialize on redstart nests, and each of these lay a different egg patterning. And that egg patterning is inherited by their daughters. So their daughters go back and parasitize the same species from which they hatched. It's still the same one single cuckoo species, parasite species, but within that single parasite species, there are females that specialize on different hosts and have evolved different egg patterning. So it's absolutely fascinating. This is true in a couple of other parasite species that have been studied. So when faced with a complicated situation like that, where you parasitize multiple host species, the cuckoos have evolved equally complicated kind of solution.
That's really fascinating. Yeah, there's another question in the chat which says normally how many eggs parasite birds are laying in the host nest?
Mm, that's a really good question. And like many answers in animal behavior and ecology, the answer is it depends. So remember the common cuckoos which throw out the eggs and chicks of the host so that they're alone. So in species like that, you can imagine if you are a common cuckoo female, you want to lay only one egg in a single nest. Because if you come back a day or two later and lay another egg, then your first hatched egg, that chick will throw everything out, including your own second egg, right? So in that situation, you don't want to ever put more than one egg in a nest. right? So for those parasite species where the chick hatches and throws everything out, they tend to lay only one egg per nest. But there are many other parasite species, including the quail, which don't throw out the host eggs. So I know that some people say that quail chicks throw out the eggs and chicks of crows, but that's not true. They don't do that. And as a consequence, they are raised alongside the crows. In those species, the females do sometimes lay multiple eggs. And it may not be just the same female, it can be multiple females that lay multiple eggs in the same nest. And in fact, when we were studying this, I think we found the maximum number of quail eggs we found in a single nest. So let me just tell you, the crows have between 3 and 5 eggs in a nest. When the quail comes in, she seems to remove one egg, crow egg, and lay her own egg. So the number of eggs stays the same roughly. And if she comes again, or if another female comes, she also removes another egg and lays her own egg. So sometimes you'll see a nest with 4 crow eggs and 1 quail egg, or you'll see 3 crow eggs and 2 quail eggs, or you'll see 1 crow egg and 4 quail eggs. And after that, it gets crazy. You might see a nest with 5 quail eggs, or with 7 quail eggs, or with 10 quail eggs. And the most extreme we saw was 14 quail eggs and no crow egg in a nest. So in species like that, you can get many eggs of the parasite species in a single host nest. Thanks for the question.
Any more questions from you all, or else there are a few on YouTube that we can take, but we'll give you, since you are here on Zoom, we'll give you the preference to ask questions. So you can raise your hand as well and ask. Yes, Abdullah. You can unmute yourself and ask your question.
Hello, good morning, ma'am. Ma'am, I got a question, a very simple question. How can a quail egg lay 14 eggs in one nest? That would be super awkward, right? 14 eggs in a nest. So how the crow eggs still keep those 14 eggs?
That's a good question. As I said earlier, we think of crows as very smart in many ways, and they are very smart, very intelligent in many ways. But when it comes to their breeding and nesting, they don't seem to be so smart. So crows by themselves, you'll never see a nest with more than 6 eggs. 6 is kind of the extreme of crow eggs alone. And here we've seen nests with more than 6, up to 12 or 14 eggs. I don't know the answer to that. I don't know how it is that crows can't tell. It's so obvious they can't tell that these can't be their eggs. Similarly, as I showed you the picture of the chicks, the quail chicks are extremely different from the crow chicks. They're a different shape, but their skin color isn't. You saw the black, very dark skin color versus the pink skin color. They're very different. So when they hatch out, you think the crows would be able to tell. And even if they can't tell immediately, but when their own chicks start to hatch, then they should be able to tell, oh, there's an odd one out. But they don't seem to be able to tell. They don't do anything to the chick. Even though crows sometimes remove quail eggs, they never remove a quail chick. So your guess is as good as mine, and perhaps you can think of interesting ways to answer the question. How is it that crows can be so dumb when it comes to this particular thing, nesting and breeding, but so smart in other ways? I don't have an answer.
Oh, okay.
Yes, Ethan, you can unmute yourself and ask your question.
So, if a quail lays an egg in a crow's nest, then at what point of time after it lays it does the crow develop a defense mechanism for realizing it's not its egg or any other species? And if so, how long does it take to actually create that defense mechanism?
Yeah, that's a really good question, Ethan. So remember that this creation of the defense mechanism, we are talking about in evolutionary terms, right? It's not like it arises, somebody teaches the crow, like you and I learn and we can figure out things to do during the course of our own lifetime, or even during the course of a week or a day, we can learn new things. And of course, birds and animals do learn new things that way. But the kinds of things we are talking about are defenses that we imagine have evolved over many generations. So remember this, a generation is like for a bird, maybe a generation is a year or 2 years. For long-lived animals like elephants, a generation might be 25 years. So when we talk about these evolutionary strategies and defenses and adaptations and counter-adaptations, we're talking about how things have changed from one generation to the next over many generations. So we imagine that this may have happened over 20 or 30 or 100 generations, or even longer, depending on what we're talking about. There are some situations where researchers have seen evolution happening in much shorter time scales. And I'm vaguely remembering, and I can't remember the details, but I'm remembering where, a parasite has newly colonized a new place where there were never any brood parasites before and have started to parasitize a host. And humans have been around to document that. And if I remember correctly, even within a few generations, like 6 or 10 generations, which is 6 or 10 years, the host species had evolved some amount of counter, strategies to or defenses against the hosts. So in some cases, it can be very rapid, but remember, we're talking about across generations. We're not talking within the lifespan of an individual bird. Hope that made sense. There was a question about counting, and somebody said, I'm sure that crows can count. And I'll just put this out there that it's really hard to assess exactly whether animals can count. How can we separate the symbolic counting from just magnitude, like 4 eggs versus 5 eggs? 5 eggs is a larger in my visual field than 4 eggs is. So how can we assess that is difficult. Researchers have tried to tackle this in various ways. It's very, very tough. So we might have an intuition that birds or crows can count, but that's a different matter from actually demonstrating that they can. Just thought to comment.
Well, there are a few questions on YouTube as well, and I'll read that out. Eden, do you have another question or just a follow-up on the earlier one? So we can just take that.
It's a different question. So if let's imagine a particular species that's the host species. And if the parasite in many parts of the world keeps switching out eggs or drops the eggs or drops the chicks, how come that host species, does their population, the amount decrease, or is there a part of the world where that same species is not decreasing?
Yes, that's a really good question, Ethan. You have a knack of coming up with good questions, I think. Yeah, so we would assume that if the parasite has a negative effect, a detrimental effect on the host, because either the chick is throwing out all the other chicks, so all the host chicks die, all the host eggs and chicks die, or if it's being raised alongside the host chicks, but it gets most of the food, like it happens with cowbirds. Cowbirds don't throw out the eggs and chicks, but they get most of the food because they beg more and they're larger and so on, and the other chicks tend to starve. So either way, the host parents don't have any babies in that, in that breeding period. So you think that if this happens, then the population of the host should decrease, correct? But of course, if you think about it, it depends on another crucial thing, which is how frequently these hosts are parasitized. So if there aren't very many brood parasites in the population, in the habitat, and only, let's say, 1 or 2% of the host nests get parasitized, then even if the parasites completely kill all the host chicks, the remaining 90 or 98% of the hosts don't have any parasites and they do fine, correct? So whether the population of the host declines depends on um, how fatal the parasites are for the hosts in each individual nest, Plus, it also depends on how many parasites there are, and therefore how frequently the hosts get parasitized. So in most cases, it turns out that it's rare for there to be a large fraction of hosts that get parasitized in the first place. It's most common to be on the order of, less than, let's say, 20% of the hosts. Now, of course, if it's more than that, and if the population of hosts start to decline, then the parasites are in trouble. And the parasites won't find enough host nests to parasitize. And what we would expect to happen at that point is for the parasites to start exploring new hosts. So if I don't find if suppose crows declined in some world and coils couldn't find a crow nest, then the female coils would look around and go even for other nests, which they don't normally, other species. And so the entire parasite species itself might shift to another host. So we don't really know about those things, but by and large, parasitism tends to be relatively low. When it becomes high, the hosts sometimes decline, and then the parasites do tend to switch to other hosts. Yeah. I hope that made sense.
There's a question on YouTube which is kind of related to this question that Ethan asked. It says there was some research that showed host chicks who survive with brood parasite chicks have a larger chance to survive for a longer time than other host chicks. Any insights on that?
No, I don't know of this research. So I can't comment exactly on it. But yeah, I mean, I would imagine that if if host chicks do survive, so some host chicks are going to die of starvation. Maybe the larger and stronger ones did survive, and they just because they're larger and stronger, they both survived as well as they did better, do better later on in life. But that's all I can think of. Most parasites do have some kind of detrimental effect on the hosts, yeah, on the host chicks. That is.
Anura, we see you've raised your hand, but we already have two people in queue for asking questions. So I'll let them ask their questions first, and we'll come back to you. So, Aradhya, you can unmute yourself and ask your question.
Why are only some birds parasitic, not all?
Well, you can imagine if all birds were parasitic, that wouldn't work, no? Because whose nest will they lay their eggs in? So the strategy, let's call it a strategy of being parasitic, only works when not all birds are parasitic. So so that's just to address one part of it. And I think to reframe your question a little bit, why aren't more birds parasitic is a question. So in the beginning of this session, I painted, being parasite as in a rosy way. If you're a parasite, you're free from parental care and you can just put your eggs in different nests and so on. Maybe it's not such an easy life after all. Because it's tough. You have to find the host, the correct host. You have to lay your egg at the correct time. In the egg laying period, you have to, maybe your eggs need to mimic the host eggs, otherwise they won't survive, and so on and so forth. And maybe it's kind of tough to evolve this set of conditions where it's successful to be a parasite. I'm just speculating. I don't really know the answer to your question. But yeah, but maybe you'll contribute to asking that question later in life, answering that question.
I hope that answer kind of solves your query,
Sometimes I don't have answers. Sometimes somebody else may have the answer, which I don't know, and sometimes no one has the answer to the question. And that's, of course, where scientific research happens. Scientific research happens at the border of our knowledge, where nobody knows the answer to a question. And there are so many infinite number of questions that nobody knows the answer to because nobody has investigated those questions yet, or because we don't have the appropriate techniques to answer the question yet. So just as a slight aside, let me say that, we learn science in textbooks. We learn all the things that we know, and we think of science as that we know everything, but that's not true. There's so many things we don't know, certainly in animal behavior and evolution. So there's a lot to explore.
Caroline, yes, you can unmute yourself and ask your question.
I wanted to ask, why do the crows keep on feeding the koyal chick when they find out that it is not their own chick?
Great question, Caroline. I can only assume that they don't know. They have not found out that it's not their own chick. That crows will take any chick in their nest and adopt it as their own, and that's why they continue feeding it. That's the only thing that makes sense. So yeah, I guess they don't know it's not their own chick. So they're not so smart in that department. By the way, let me add to that. When the chicks grow up, when the koel chicks grow up, and they get their feathers and they open their eyes, they move around, and they begin to resemble the adult koels more and more. Even then, so long as the chick is in the nest, in the crow's nest, the crows don't do anything at all. The crows just keep feeding them. But at some point, chicks have to leave the nest, right? So they first perch on the side of the nest, and then they'll perch on one branch away, and then they'll fly a little further, and so on. So at that point, they look very much like adult koels. And at that point, the crows suddenly start to recognize them if they are not in the nest. So sometimes I've seen koels who have just left the nest. If they've perched at the nest and they fly to the next branch, immediately the crows get all upset and angry. But if they come near the nest and sit in the nest, then the crows calm down and they behave as though there's nothing wrong. So the crows have some switch in their brain, it seems, which says that anything in my nest is mine and I'm going to love it like my own. But if there's something outside the nest, then my other recognition system switches on, and I look at whether it's, a predator or a parasite, and then I'll act accordingly. So it seems like there's something like that.
So to add a question that popped up on my mind when you were saying, like you said that they don't go like if they don't feed them if they're outside their nest. So
Mhm.
there will be a point when they cannot go back into the nest because they have grown to a certain size. Is that the point when they don't need parental care, or they just figure out how, like, getting fed by the crows?
Yeah, I mean, obviously all birds, even the host birds, at some point they don't need parental care, and they can feed themselves and so on. So typically with the many host species, most birds, they leave the nest and then they still wander around with the parents. So there might be three, four chicks and two parents, and they go around the habitat and they keep feeding them, and they feed them less and less, and finally the chicks become independent. So with the coils, this probably happens faster because they have a head start. They hatch earlier, they grow fast, and it seems like they develop faster also. They get their feathers before the crow chicks, their eyes open before the crow chicks, and so on. So there's some nuance to this, but by and large, it looks like as far as I understand, the coils develop fast and they become independent faster, and then they don't need the crows anymore. And at that point, it's a good thing they don't need the crows anymore, because when the crows see them, especially when they see them fly, their aggression instinct kicks in and they start to chase them. Not recognizing that this is my chick that used to be in my nest, just that this is a coil, is my enemy, I need to chase it. So yeah.
Yes, Anurag, unmute yourself and ask your question.
And I have a question that when a pair of crows nested in a mango tree nearby my window, and a coil used to call all night beside the crow's nest. And why do they do this? Why did it do it? It called all night beside just beside the branch where the crow made its nest, and it started calling. Why do they do this?
That's a great observation and a really interesting question. I don't know the answer, but we can speculate. No, we can speculate. One possibility is that generally coils, it's the male that sings that song, no? So males are singing, the females don't sing that song. One possibility is that males in the breeding season, they are singing all through the night everywhere. So it might have just been chance that the tree that this male decided to sing from also had a crow's nest. So that's, some things are chance. Another possibility, more interesting possibility, but doesn't mean it's true, is that this male quail found a crow's nest and is trying to advertise to uh, potential partners, females, to say, look, come, I've got a I've got a nice juicy crow's nest here that you can lay your eggs in. Uh, could be, I don't know, but it's an interesting observation. And what would be very interesting is if you and others also saw this repeatedly, that where there are crows with the fresh nest and eggs, you particularly tend to see quails come there and call, as opposed to places, nice trees which don't have crow's nests. One thing I should say that if this had been in the day, then maybe the crows would have chased the quail. But I think in the night, the quails can still sing, and they do, but the crows are asleep. I don't think they try and chase quails in the night. But in the day, it can be very dangerous because quails do get chased by crows, and sometimes they even get killed by crows during the breeding season. So crows do have a very strong kind of image of quails as an enemy. And just to address a question here in the comments, I mentioned that the crows seem to accept all the chicks in their nest as their own. And the question here is, if that's the case, then why would they throw out the odd eggs? So most of these host birds, Shakti, it seems to be this switch again. At the egg stage, they often discriminate, and they tell the difference between their own eggs and some strange looking egg. But once the eggs hatch, that discrimination seems to go completely. Except for just a handful of species that seem to discriminate chicks also, but the vast majority of species only discriminate at the egg stage. Now, why that might be is a slightly more involved kind of argument and speculation that I don't think we can get into now. But there seems to be this switch at the time of hatching. Once something is hatched and there are chicks in the nest, my love, shows no limits, and I love everything in my nest. But before that, I'm a little more suspicious. Don't know.
Yes, Caroline. Caroline, you can unmute yourself and ask your question.
I would like to ask, what do crow babies eat?
Yeah. Nice question. So crows, as you know, are omnivores. They'll eat anything and everything. So all kinds of rubbish, dead things, bandicoots killed on the road. Um, they'll eat insects if they can. So sometimes, if after the rains, you'll see these swarms of termites coming out of the ground. And when you have that kind of eruption of termites, then crows will eat those termites too. So adult crows will eat everything. The chicks, of course, are a little more discriminating. They can only have food that's small enough for them to swallow. So the crows bring them torn up pieces of meat. They'll bring them insects. As they grow older, they also bring them fruit. Fruit typically is for a little bit later in life, because when they're small, they really need to grow and they need lots of protein. So they give most chicks of most species of birds are fed protein-rich foods when they are very small, and then maybe supplemented by some other things as they grow larger. Yeah, so lots of animal food when they are smaller, and then some fruits as well when they grow larger.
I'll take a question from YouTube first right now. The question is, pied cuckoos, are they facultative parasites? They can build their own nest and also parasitize other nests. If there are such species, what triggers them to choose a particular strategy?
That's a nice question. There's also a question by Ethan here in the Zoom chat. Are the hosts of some parasites, are they parasites themselves? So what we're talking about right now is we're talking about obligate brood parasites. Those that have no other, they don't do anything else. They're only parasitic on other species. That's 100 of those species. And that includes pied cuckoos. Pied cuckoos don't build their own nest. They have to parasitize other species. And pied cuckoos specialize on babblers like jungle babblers and large gray babblers and so on. And by the way, pied cuckoos' eggs also mimic the color of the babblers almost perfectly, so perfectly that it's hard for a human researcher to see, or anybody to see the difference. A very, very subtle difference, much more perfectly than the quails mimic the crow eggs. So the pied cuckoos are obligate parasites. They don't build their own nests. Um, there are there are some species, actually many species of birds that parasitize other individuals of their own species. So they will have their own nest and lay their own eggs, but in addition, they'll put a few eggs in other nests of the same species. So these are there are about 200 or over 200 birds have been known to do this species. And it's just a way of not putting all your eggs in the same basket, right? You don't put all your eggs in the same nest. And there are some situations where, again, we can discuss maybe another time why some birds would do that. So these are not the brood parasites that parasitize other species. They're only parasitizing other individuals of their own species. So I might lay 6 eggs in my nest, but I'll also put 1 egg in a different nest and another egg in a third nest. That happens. But you don't have these facultative parasites that sometimes parasitize other species and sometimes build their own nest and lay their own eggs, so far as I know.
So, Ethan, go ahead. You can unmute yourself and ask your next question.
Yeah, so I have two things one to ask, one to tell you. So if a parasite, it lays the eggs, then what is it doing after it lays its eggs?
Okay, and you want to tell me what you want to tell me, and then I can answer.
Yeah, the other thing is I have to leave. So
Okay, so I'll quickly answer this question. They hang out. I mean, birds, they eat and they rest. Some parasites are migratory, like the common cuckoo that we have in India and is all across Europe as well. So the common cuckoos, what they do is they quickly lay all their eggs in different host nests, and they don't have to hang about. So they just leave. They fly. They migrate. They migrate to Africa in the winter. So they just leave on migration, and they can leave early because they don't have to take care of their young ones. The hosts have to take care of the young ones, and so the young cuckoos, when they hatch out, their parents have already left. The parasite parents already left and gone to Africa. And then the young ones, once they can migrate, they have the feathers and the strength, they leave. So those common cuckoos, they spend most of their time in Africa, chilling and getting fat and strong for the next breeding season. And the hosts do all the work. So yeah, they just do other things. They don't have to take care of the young.
bye and thank you for the session.
Bye. Thanks, Ethan. Thanks for the good
like
question.
those choice questions where you could answer any.
I'm glad. Thanks. Thanks, Ethan.
Bye.
Bye.
Before you leave, there's a feedback form if you can take a minute to fill that out. And even for others, I've shared a feedback form. It would be nice to, if you can fill that. And I see that some of you have also suggested what you will like to hear from like sessions on for the next future sessions, what you would like them to be on. So you can mention that in the feedback form as well. So please take a minute to fill that.
Okay, but I have a question. Like, how do I fill the feedback form?
There's a link in the chat I have shared right now.
Yeah, I can see it.
Yes, you can click on it, and there are like 2, 3 questions that you'll have to answer.
Okay. Bye.
Bye. Thank you for joining. This okay. There was one question a while ago in the chat which asked, do even insects uh, do this? Do you know of any insects which also are brood parasites?
Yeah, most of them are not brood parasites in the way that birds are. There are insects called cuckoo wasps and cuckoo bees. They're called cuckoo because they're sort of like these cuckoos, like the brood parasites. So the cuckoo wasps, they lay their eggs in the nests of other wasps, and then they eat the food that the parents have provisioned. So, many of these potter wasps or paper wasps and so on, they make a little cell, a home for their young ones. They put an egg or two, they provision it with paralyzed spiders and caterpillars. I don't know if you guys know this. And then they seal the entrance. And if before they seal the entrance, the cuckoo wasp comes and sprays an egg of its own inside there, then that hatches first and it eats the uh, food that has been already provided. So those are sometimes called brood parasitic insects. Otherwise, they're called kleptoparasitic. Kleptoparasitism refers to stealing. They steal the food that's already there. There are a few other, one or two other insects, I think, which are where the parent, host parent comes and feeds them. I can't remember which ones they are at the moment. And there's also some brood parasitic fish, by the way. Some of them are these mouth brooding fish. I don't know if you know, in some species of fish, after the eggs are laid, the mother or the father in some species keeps the eggs in their mouth and keeps them safe that way. And once they hatch, again, the hatchlings, they roam around near the adult, near the parent, and when there's danger, they go back into the mouth. So these are called mouth brooding fish. And there are some parasites on those mouth brooding fish, which lay their eggs and it gets accepted like the egg of the host, but then it actually eats up all the young ones of the host. So yeah, there are most brood parasites are best known among birds, but there are a few insects and there are some fish as well that are brood parasitic.
We are a few minutes beyond 12, but we have 2 more questions on from YouTube that I'll quickly ask. I'll just quickly ask the 2 questions and you can answer them. So one question is also something that I had on my mind is, how do baby koals learn to sing if they are raised by crows? And the second one is, in a group of 10 nests near my home, only one was parasitized. What are the factors for choosing?
Oh, tough. So this learning the song of your own species that is most fine-tuned or most well-developed in a group of birds called songbirds or passerines, perching birds they're called sometimes. So examples here would be, magpie robins and I don't know, pied bush chats and things like that. Not all passerines have elaborate song, but some of them do, and they tend to learn from their immediate, their parent, their fathers, the parent that sings. But the non-passerines, which includes cuckoos like koels, they tend to have very simple songs. Like the koel song is extreme, just 2 notes, very simple. And we don't know in particular with the koel, but my understanding is that the cuckoos, for them, the song is innate. That is, they don't have to learn the song. They already know the song. So if you raise a cuckoo or koel in a soundproof box where they don't hear anything, with a magpie robin, it probably won't be able to sing a song as it when it grows up because it needs that hearing and feedback. But with the non-passerines, as I understand it, I may be mistaken, they don't need that and they just sing their simple song without having ever learned it. So in some birds, songs are learned, in some birds they're not learned. They just are innate or inherent in the bird. And about the other question, that's hard to say. With some of the work that we had done earlier in villages where these crows were nesting, we found that the nests on the edges of the villages were more likely to be parasitized than in the middle of the village. And that's probably likely because the edge of the village is safer for koels because they can just come in from the outside, lay an egg, and go. But to get to the center, they have to escape lots of crows that start chasing them. So in the center of the village was a dangerous place. This is our speculation for koels. But the edge was, so it's possible that in your group of 10 nests, if this thing is happening, that it's one of the edge nests or the furthest one away, nearest to some tree or bush or some cover where the koels could hide. And the other nests maybe were in a more dangerous place where more open and crows could see the koel come in and therefore would chase it. Again, that's just a guess about what could be happening.
Thank you, Sohail, for answering all the questions. And uh, are there, we can maybe, I hope there are no more questions. So if you do have any more questions, you can write to us, you can send it to us, and we'll make sure that we respond to you with an answer as best possible. And so thank you, Sohail, for such a wonderful session. And you can see in the chat box itself how we kids have loved it. And we have similar comments on the on YouTube as well. Uh, Thank you for the session, and thank you everyone for joining. And I hope you all took a minute out to fill the feedback form as well. If you have not, I'm sharing it again, and you can uh, fill it out. And to let you know, next month we'll be having a session on bats. Last month we did a session on moths, and you all, if you attended, you would have heard of bats being mentioned quite often in that session as well. So we thought, well, why not just bring bats to you? And next uh, session, I will announce the date and all the details soon, but I'm giving away the session topic so that we see you again next month as well. So thank you everyone for joining, and thank you, Sohail, for.
Thank you. Thanks, Amrita. Thanks, everybody, for joining. Bye.
Bye.